Have you ever gazed up at the night sky and wondered what secrets those twinkling lights hold? Today, we're going on an extraordinary journey, a cosmic plunge into one of the most spectacular and violent objects in our galaxy, the Rayet star, WR 124. What would happen if you fell into this stellar behemoth? Buckle up, because this is going to be one wild ride. First, let's get acquainted with our destination. WR 124, in your average star like our Sun, it's a massive, scorching hot, and incredibly luminous Rayet star, located about 15,000 light-years away in the constellation Sagitta. These stars are cosmic titans in their twilight years. They've already burned through the hydrogen in their cores and are now furiously fusing heavier elements. This process makes them unstable, unpredictable, and frankly, terrifyingly powerful. Imagine a star 30 times more massive than our Sun, shining with over 150,000 times its luminosity. Its surface temperature is a blistering 50,000 Kelvin, nearly 9 times hotter than the Sun's surface. But the most defining feature of WR 124, its ferocious stellar wind. It's shedding its outer layers at an astonishing rate, blasting material into space at speeds over 1.5 million kilometers per hour. That's fast enough to travel from London to New York in about 12 seconds. This ejected material doesn't just disappear. It creates a stunning, chaotic nebula around the star, known as M1 to 67. The James Webb Space Telescope recently gave us a breathtaking new view of this nebula, showing intricate filaments and clumps of gas and dust glowing brilliantly from the star's intense radiation. It's a celestial masterpiece, painted by stellar fury. So, what if you were on a hypothetical, indestructible spaceship approaching WR 124? The first thing you'd notice, even from millions of kilometers away, is the overwhelming light. It would be an incandescent, brilliant white-blue glare that would outshine everything. You'd need some serious filters to even look in its direction. You'd also feel the heat, an intense wave of radiation washing over your ship. As you get closer, you'd enter the nebula, M167. This isn't some gentle, ethereal cloud. It's a turbulent storm of superheated gas and dust. Your ship would be battered by particles moving at supersonic speeds. It would be like flying through a cosmic sandblaster, but with each grain of sand being a superheated atom. The nebula itself is a kaleidoscope of colors, with glowing hydrogen, helium, and nitrogen painting the cosmos in vibrant shades of red and blue. Your instruments would go haywire. The magnetic fields are immense, and the radiation is off the charts. We're talking gamma rays, X-rays, the whole electromagnetic spectrum turned up to 11. Any standard electronics would be fried in an instant. This isn't just a place of beauty, it's a zone of extreme danger. Now for the main event, the plunge into the star itself. Defining the surface of a star like WR 124 is tricky. It doesn't have a solid surface like a planet. Instead, it's a ball of plasma that gets denser and denser as you go deeper. We'll consider the point where the gas becomes opaque as its visible surface, the photosphere. Breaching this surface would be instantaneous and final. But let's imagine our indestructible selves could experience it. The moment you cross the photosphere, you are inside the star. The temperature and pressure would skyrocket to unimaginable levels. We're talking millions of degrees Kelvin. You would be surrounded by a swirling inferno of super-dense plasma. The sheer gravitational force would be crushing. Being 30 times more massive than the Sun, WR 124's gravity is immense. The tidal forces alone would be enough to tear any object apart, stretching it into a long, thin strand of atoms, a process called spaghettification. Even if you were somehow immune to the heat and pressure, gravity would deconstruct you on a fundamental level. You wouldn't be falling in a traditional sense anymore. You would become part of the star's convection currents, vast, churning rivers of plasma carrying heat from the core to the surface. You'd be swept along in this stellar furnace, witnessing the raw power of nuclear fusion firsthand. The core of WR-124 is a fusion reactor of cosmic proportions, forging elements like carbon and oxygen from helium. The pressures in the core are so extreme that they could squeeze a car into the size of a sugar cube. The temperatures reach hundreds of millions of degrees. Here, the very fabric of matter is ripped apart and reassembled into heavier elements. To witness this would be to see the engine of the universe, the very process that created the elements necessary for planets and for life itself. But the story of WR-124 doesn't end with a gentle fade. Stars this massive have a spectacular and violent finale. They end their lives in a supernova, one of the most powerful explosions in the universe. In the blink of an eye, WR-124 will detonate, briefly outshining our entire galaxy. This explosion will blast its newly forged heavy elements across space, seeding the next generation of stars and planets. The carbon in our bodies, the oxygen we breathe, it was all created in the heart of a star like WR-124 and scattered by a supernova. So, in a very real sense, we are all stardust. Falling into WR-124 would be a journey of ultimate annihilation, but also of ultimate creation. It's a humbling reminder of the incredible scales of power and time that govern our universe. The beautiful, chaotic nebula we see today is just a prelude to an even grander cosmic fireworks display. It's a testament to the fact that even in destruction, the cosmos finds a way to create something new. So the next time you look up at the stars, remember the story of WR-124. Remember the violent beauty, the raw power, and the creative force churning within these distant suns. They are the crucibles of the cosmos, and we are their children. Thank you so much for joining me on this cosmic adventure today. If you enjoyed this journey into the heart of a star, don't forget to hit that like button and subscribe for more explorations of our amazing universe. Let me know in the comments what cosmic mystery you'd like us to dive into next. Until then, keep looking up,